Or
The volume of the sample?
so is it going to be in grams? Is volume in grams or milliliters? Think about it.
Is it in grams?
That's mass.
So it's in-
Milliliters is volume. Yeah. It's like this. I'm coming around and check it. Cylinder from yesterday. The knowns were in 1 milliliter increment. So we have 90, 91 to 95, 96, 97, all the way to 100. So the guess is going to be between 90 and 91, or any dash between your knowns. So these are the known dashes. So your guess would be like 90.5 or 90.1. Now today with the 25 milliliter graduated cylinder, you have a 10 milliliter mark and you have an 11 milliliter mark. But you have a mark in between the two at 10.5. So these are your knowns. So it's not going to be just 10 like over here you see 90. It's going to be 10 decimal because you have 10.5, then you have 11, then you have 11.5. Is everybody clear? So your guess is going to be between this and this, whether it's going to be 11.41. That's going to be your guess there. So this is a little more tricky. It's happening here. If it's 11.5, it's not going to be just 11.5. It's going to be 11.50. This is how it makes it a little tricky. You want to write it down, what you know first. So these are the knowns. This is a known right here, 11.5. So if it's 11.5, this must be 11.0. So I always write down what I'm given first so that I know I'm given the correct data. When you're doing this, this can be a little bit tricky. That's correct. You can see it on the overhead. Did you get hydrogen?
Yeah, 1.2% and 14.3%, 57.9%.
Excellent. 42% is correct. So you can see the rest of those on the overhead. So those answers. Okay, students are measuring the graduated cylinder again today. So from yesterday we had 100 graduated milliliter cylinder. If we have a volume here at a little over 90, your known is going to be between 90 and 91. So we're going to say it's 90. The estimated is between these two, between 90 and 91. So we're going to say like 0.5. So our estimated guess is between these two, and we're saying it's around 0.5. Now we're working with a 25 milliliter graduated cylinder today, so the estimation is going to be a little different. The knowns are at 10, 11, and then there's a dash between the two at 10.5. So that is your known. So if you have a volume between 10.5 and 11, you have your known, then you have your estimated. So we're going to say 0.4. This one is a little bit, I guess you would say, less reliable because the guess between the 10.5 and the 11.0 is a lot larger. This is a less reliable graduated cylinder compared to this one. Right, they're not the same.
That's right.
So you can see up here the answers. A little bit, not the same. Students were measuring the water in the 25 milliliter graduated cylinder, and what did we come up with? A answer for 6.27 divided by 6.60? 0.95 grams per milliliter. That's the density of water at room temperature. Now what do we have for that one?
12.88.
So we have 12.88 grams divided by 13.30. What's that equal? Yeah, you can put it in the calculator. Precise grouping so far. We just did two of them because the bell's getting ready to ring because of advisory. Does this look like a fairly precise grouping, just the two of these? Yeah, we're in the right direction considering there was measurements were made by more than one person. Excellent. Four.
The volume of the sample?
So is that going to be in grams? Is volume in grams or milliliters? Think about it.
Is it in grams?
That's mass.
So it's in
Milliliters is volume, yeah. Always necessary. It's not always necessary to remember the units associated with the problem. If you can write down the units that they give you, 61.3 grams, 8.96 grams per milliliter, and you can cross out and get the correct unit without having to try to memorize that volume is a milliliter. So again, we've taken some measurements with the 25 milliliter graduated cylinder. For the first one, our data recorded a density of 0.73. Now that data is not consistent with 2 and 3, so our overall data is not precise. Does everybody understand that? Overall data not precise. Alright, so continuing on in the book, talking about percent composition. We will most likely color this tomorrow. This periodic table. And it shows us the name, the symbol, the number. There are 2 numbers on every element on the periodic table. Anybody know what those 2 numbers are? Raise your hand. Alright, Christian. Let me advance. Yeah, the atomic number and the mass. Very good. So what does the atomic number tell you, Vance? What does the atomic number tell you? Number of, starts with the P. Atomic number of, raise your hand. Protons. Yeah, and why is that significant? Why is the atomic number significant? What does it tell us? It tells us what the thing looks like. Gold looks like gold because of the atomic number. Platinum looks like platinum. Raise your hand if you judge a book by its cover. Y'all lie. Yeah, you do. Everybody does. You know, people look at you and they're going to determine what you're like based on what you look like. Yeah, that's why the atomic number is so important. 1.33, is that grams?
Yes.
Percent composition and percent by mass.
Percent composition is how much it's made of.
Percent composition is really based on analysis or actual lab work. This percent composition is based on theoretical. So you can theoretically calculate this is what you're supposed to get based on how we separated the elements into different groups. You're going to see that tomorrow when we color them. But magnesium has been tested and found to have a mass of 24. So this is going to be theoretical. This is much more reliable. So when you start doing an analysis in the lab, you're going to compare it back to this. So you go out and you find an unknown somewhere, and you find out that it's 28% magnesium. You're going to say, okay, then it could be MgCO3. This is the standard. The periodic table always provides us a standard that we can go back to and check whatever we've found in nature. Because we're always finding new things in nature. Did you know that? Like a new rock or they found new species just about once a month. New species are found.
You don't think you were a teacher?
Of water, we have 9.96 grams divided by 10.2 milliliters. Anybody got number 5? Raise your hand. Number 5. Cody? They got 126.01. The total mass is just add all of it up. So they have 34,
Oh, you're talking about the paper. Oh, shoot.
1.51, 18. Alright, number 6. Raise your hand. Anybody? 6? Number 6. Oh, there is a B? What'd you get for B?
For sodium, I got 27.3.
Excellent.
Cheers, sis.
And did you get?
No, he's Bernie.
From Barney?
He's from the TV show Barney? The hit TV show Barney?
Borneo, that's what it is. Borneo.
Huh?
One of the two. They both sound alike. I don't know.
Probably Boston. Never heard of
Maybe.
Boston.
You should.
Oh, I got it right.
Excellent, Ryan. Now today, Ryan wrote down all the units, which is really good. So he's getting ready to work in the workplace. Now they don't require you to do that on the ACT, obviously. You just bubble in. But when you get to where you're going to work somewhere, you want to write down everything because you'll forget. Trust me. 3 weeks from now, you'd be like, density. What's that? Percent by mass. We graded them for completion. We just want to make sure that students are on the same page. Seven is an element, so you can check your work. There are the answers on the overhead. Is the data in this measurement for the density of water precise? Raise your hand. Kaya? Yes, it is precise, because they're very close to 0.9, right? So if you were measuring that, that's periodic table. You go to the periodic table, find the mass of magnesium, which is 24, the mass of carbon, which is 12, and the mass of oxygen is 16. Our formula is MgCO3, and you add that together and you get 84. You can see that in red there, 84.32. So from that, then you take the mass of the magnesium itself, divide it by your total, times 100, and you see that it's 28% magnesium. Now from this we can determine the formula. That's the next step. We're not there yet. We just want you to understand that we can determine the percents. And this is what we typically do when we find an unknown substance. This is the first step. Determine what is in the unknown substance. How much magnesium is there. So we can test for certain elements. Does everybody understand that? We can test for elements. Any question on that? Test for elements, determine the percent. So here's finding percent by mass. We had 8.44 grams of carbon out of the 20 grams of sucrose, and we got our percent based on the analysis of the substance. But now we can actually go to the periodic table and we can determine the mass and then determine the formula. So calculating percent composition is kind of the next step after finding percent by mass. Okay, we're going to introduce percent composition. Percent composition, Noah, today we're introducing that. Now in the book yesterday, they did a sucrose analysis. That is, in the lab, they had to determine the amount of carbon present in the sugar. And 20 grams, and they determined it to be 8.44. Now let's say that you have an unknown substance, right? First thing you're going to do is determine what elements are in the substance. And then you're going to determine, you're going to separate them into groups. So you got carbon, magnesium, and oxygen. Now you can do this out of 100 grams, would be a lot easier. And then you could determine what percentages you have, like we showed you yesterday. But oftentimes, we want to look back and find out what the formula is. So that's when we use the periodic table. So over here on the periodic table, there's some data on it. You have a small number and you have a large number. What does the small number tell us, Noah?
Tell us how many atoms.
Tell us, what does 6 tell us? Raise your hand. John? That's okay. What does the 6 tell us?